Thank you. Uh, I'm Devang, and today I will briefly talk about Olive. Earlier, I was worried that my talk is just before the lunch, and you all will be hungry and won't pay attention. And now, I think since you had lunch, you will be drowsy and may not pay attention either. So I think that's good. So today, I'll cover like what is the problem we are trying to solve at Olive. It may not be the same problem that you are thinking. What's the approach, how we are doing it, and how you can use Olive, and how you can extend Olive afterwards. So what is the problem that we are trying to solve? So we all know that when you have a pre-trained model and you want to put it in a production, it's a long journey. You want to fine-tune model sometimes. You want to definitely quantize the model nowadays. You want to compress, prune the model. Eventually, you want to convert into ONNX. You may want to apply a few surgeries. You want to do some graph transformations. You want to do operator fusion. And the list keeps going. And when you do all of this and more, then eventually you have a model that you can put it in production. The challenge is that whoever is going through that journey, they have to figure out all these packages, all the libraries, all the tools out there. They need to know that they exist. Second, they need to learn how to use that tool. Like just before the lunch, Justin showed us the ONNX script, ONNX IR tool. But not only you need to know that it exists, you need to learn how to use it. And then, once you learn one or two tools, then you need to figure out that there are so many tools and packages and things that is available. How do you use them with each other? Which one to use first, which one goes next? Do you quantize first or you want to fuse first? I don't know. So that is all the challenges. And on top of that, all these packages and libraries and quantization tools, the compilers, they are oblivious of each other. They don't know, they don't realize that other package exists. But as a user, as a model developer who is trying to put the pre-trained model in the production, he needs to connect a thread between all of them. And I believe that is the challenge, and that is the challenge we are trying to address at Olive. The purpose is that we want to accelerate the process of getting the pre-trained model into production. I know many of you are focusing on running the production model or accelerating the model in production. But here the focus is, how can I get you, how can we get going faster and faster and faster? So then the question is, isn't it just about the exporting the model? And we have Torch exporter, Dynamo exporter, model builder, Optimum exporter, and few more exporters are out there. Then isn't that all you need? And by the way, all four of these exporters we have integrated in Olive. So then the question is then, what else you need? Why do you need Olive or anything else or equivalent to Olive? So let's ask ourselves, is it just the exporter capturing the graph in ONNX form? Obviously, you want to apply operator fusion. And I kept this slide empty because there are many, many reasons you want to do the fusion. You want to do it for performance. You want to keep the tensor in the accelerator memory. You want to increase the utilization of your accelerator. You want to increase the throughput of your model. You want to use the fusion depending on the hardware that you are targeting. In terms of ONNX runtime, that would be the execution provider. And sometimes you definitely want to fuse the operators based on the kernel libraries that you have. Sometimes you want to fuse the operators because you want to use a custom operator that you have. Or sometimes you want to fuse the operator because you want to use the country operator library that available with ONNX runtime or other runtimes. So there are many, many, many reasons you want to fuse the model. And there are many, many reasons you want to fuse the same ONNX model differently for different reasons, for different use cases or different criteria. So that is one thing. It is beyond exporter. The second is, it's a graph. And there are always many, many opportunities to optimize the graph, find opportunities. And at one point when we looked at, there were 5 or 6 different ONNX graph optimization or graph transformation or graph simplification libraries available. And all of them were doing one or other things, but there was no superset of that. If I want to do everything or I want to have access to all of them, it wasn't there. And now I see, knowing Justin, that he is trying to race and do all of them in ONNX script. This is awesome, but this is an ongoing challenge. And as we see new models, new architectures, we'll see more and more opportunities to apply graph transfers. So that is another need. And we don't want to keep doing this same optimization for each exporter again and again and again. Otherwise, we won't go very far. Then another thing is that you want to apply what we call the graph surgeries, where you want to modify the graph, you want to model change the model for one or other reasons. And there is a saying that a good lawyer is not the lawyer who tells what is legal and what is not legal. Good lawyer is the one who gives a legal part to whatever you want to do. Same way with Olive, we want to make it easy and simpler to apply whichever graph surgery you want to apply for whatever reason you want to apply. We just want to make it easy. And the big thing is the quantization, and there are many precisions when we talk about quantization. int 8, int 16, and NF4, and I know that this is not the entire list of precisions out there. And then there are different algorithms, AWQ, GPTQ, Caret, SpinQuant, HQQ, and there are many more. And this area is under heavy development and research, so we'll see more and more algorithms. On top of that, there are many approaches how you want to quantize your model. Dynamically you want to quantize, or you want to statically calibrate the weights yourself. You want to quantize only the weights, or you may want to quantize activation also, but then it's different precision for certain weights and certain activations, and so on. Then, and I'm sure people will keep coming up with a new and new approaches to do the quantization. And we obviously have many quantization libraries available to quantize the model. Some of them quantize the model in PyTorch, some of them do it in ONNX model, some of them do it in ONNX and PyTorch. Here is the list that I found, and I missed the NNCF that Yamini mentioned earlier, and I'm sure I'm missing few more. And if you are the model developer who were trying to get the pre-trained model production ready, then you have to navigate all of this. And the challenge is that all these implementations out there, one way or other way, they are specific to certain models, but not all models. And each of them supports certain precision, but not all precisions. They support certain algorithms, but not all algorithms. The documentation is all over the place. So as a user, you have all of them available. You can do pip install all of them, but you will suddenly you many times find that instead of worrying about how do I optimize or make my model production ready, you start worrying about how do I figure out how to use which tool and when. So that is why in Olive we are trying to solve that problem, and by using a very simple architecture. So Olive architecture, we build an Olive engine that can schedule the different passes the way you want in the order you want. And each pass can be one of this tool can be each pass, like GPTQ can be a pass, Dynamo Converter is a pass, Model Builder is a pass, and so on. And now once you have a collection of passes available, then you can schedule the way you want for your model. And now the engine has the capability to use any host that you have available to run your transformations. And it can target any accelerator or hardware that you are trying to run your model on. And now all this n by n matrix Olive makes it easy for you to handle. And on top of that, you want to measure the quality of the model, you want to measure performance of the model, so Olive can do the latency measurements. It allows you to measure Hugging Face matrix, torch matrix also, and it's a plug-in architecture, so you can easily plug in LL evaluation hardness also if you want to measure the quality of LLM. So the idea is that if this simplistic modular architecture that we can easily extend allows you to move faster, experiment faster, and get your model in the production sooner. So quick example of how we can do it. So like we ran into this situation recently where the data scientists wanted to quantize the weights 4-bit using GPTQ algorithm. And they wanted to run only the certain operators on NPU and certain operators on CPU for one or other reasons. And obviously they wanted to convert the model into ONNX, and then they wanted to do the activation quantization in ONNX and apply few graph surgeries. And then obviously, don't forget, they wanted to run only certain operators on NPU. So Olive helped them in the sense that we all know that when the model is in PyTorch, you have a better understanding of the model architecture. So if you are making a decision to partition the graph or decide where to run which layer or which operator, you have a better chance to figure out, go through algorithmically. But then when you lower the model, quantize the model, you lose that information. So in Olive, we have a path to collect that information, and then we preserve that information during different conversations. And all these steps now in Olive, you can just describe in a JSON dictionary or an YAML file. We only have 2 YAML users. Most of our users are JSON, they like JSON, but for us it doesn't matter. And suddenly, instead of extensive cryptic Python script that only works for one model, now we suddenly have a dictionary of what you want to do, and now you can easily use it for different LLMs, and you can easily extend. If you want to add additional 1 or 2 surgeries for your NPU, you can easily do that. So that's one of the key advantage of Olive. And so I'll now talk about briefly how to use it. I mentioned the JSON config. So this is the one entire config of one scenario where you want to load the Hugging Face model, you want to do the ONNX conversion using torch script, and then you want to apply the peephole optimizer, and then you want to do the blockwise 4-bit matmul quantization. You just list that, and you just say where do you want to put the output model, and that's it. Now you don't have to go and chase the matmul 4-bit script that we have in ONNX runtime and learn how to use it, because that's not the point, right? We also have a few command line options, and this command line option internally just generate the JSON config and run it. So like in Olive, we have almost more than 40 passes to do different things. And we group them in these command line options. Like one is to quantize, where you can just select the algorithm, precision, and the target. And Olive will pick up the right package that supports that combination that you want and run it. You want to capture the ONNX graph? Yes, you can just use simple command line. You can use torch script, model builder, or Dynamo, either, whichever works for your model. It works fine. And we have something called auto optimizer, where based on our observation, we provided a pre-selected list of passes that you want to run. So that also works. And as I said, these command lines are just a wrapper around how you produce the config file. You can write your own. If you're paying attention to Olive's GitHub repo, Friday I was trying to teach a GitHub Copilot agent to create a new command line and so far it's doing well. Let's see. So this is how you use Olive. Either you generate or use a config file, or you use a command line. And the advantage of config file is that now you can build an additional layer on top of it, like the VS Code extension or whatever workflow you prefers. And the last thing, how do you extend Olive? In Olive, you can extend, add a new pass. You can add a new evaluator to measure the quality and performance of your model, as well as you can add a new accelerator or a system. Everything is plug-in and easy to do. I'll just give you one quick example how you add a new optimization pass in Olive. You just derive from a pass class. You define the configurable knob that each pass has, because I know each tool has their own ways to let users select what they want to do. And then you'd implement the run config method to run your pass. Olive will give your method the input model. Your task is to produce a valid input model. Olive will also provide you the options and choices that user has made or what user is trying to do. And so you have all the context in it without worrying about anything else before. And Olive will make sure that you can connect dots from one to another. And this is the entire pass that you need, or we have written it, to do the ONNX script IR optimization that Justin was talking about. So that's a brief overview of Olive, what it is, what it does, and how can you use it, how can you extend it. Any questions? Thank you. So I was correct. Okay, go ahead, Justin.
Is there any plans to make it more tightly integrated into ONNX ecosystem?
In what way?
I guess, for example, a lot of times we think of Olive and kind of target kind of ONNX runtime usages. So does it, for example, support routes that's not targeted toward ONNX runtime? What about other?
So Olive, yeah, since we are, we are at Microsoft is developing, but it is an open source and it is not tied to ONNX runtime. All the ONNX runtime specific work is in a separate passes. So when you run Olive to produce an ONNX model that you want to run it with another another runtime, you can easily do so. You just keep the passes that are using features or operators that are only available in ONNX runtime. But you don't have to use those passes, so yeah.
Thanks.
Thank you.